how does turning on the lights cause climate change? You've heard about climate change in the news, you've read stories and articles about it, but what is the actual science behind what is happening? To answer that, we need to go back to the fundamentals, carbon. Carbon is an element that is the force of everything on Earth, from humans, plants, animals, bacteria, fungi, and even viruses. Carbon can be found in molecules all over Earth, in our soils, our fossil fuels, our atmosphere, and our oceans. Now, like other elements, carbon cycles around Earth. You probably learned about the water cycle as a kid, how water moves between our oceans and our atmosphere. Carbon's pretty similar, but there's a lot more locations and a lot more pathways. For example, the process of photosynthesis is where plants take carbon dioxide out of our atmosphere and incorporate it into plant tissues. Another way carbon moves is the carbon found in dead organisms eventually makes its way into our fossil fuels. Now, you might have noticed there's no natural pathway for carbon to leave fossil fuels. It's probably going to stay there for a couple 100 million years. That's where humans come in. Humans are introducing new carbon pathways into this system, most notably combustion. Humans have used their ingenuity and innovation to harness the energy found in the carbon bonds in our fossil fuels, such as gasoline to drive a car or natural gas to use our stovetop. Now, that's where the problem lays. When you make a fire, which is what combustion is, you need three things: an ignition source, a fuel source, and oxygen. When humans burn carbon-based fuels in the presence of oxygen, they're going to create carbon dioxide. That's a fact, and there is no debate in the scientific community about that. But what's happening is all that carbon was in fossil fuels, and now humans are funneling it into our atmosphere. So now we know when you flick on that light switch, you're burning fossil fuels somewhere, which is releasing carbon dioxide. So what? Where does climate change come into that? We need to learn a little bit more about carbon dioxide. Carbon dioxide is a gas that is colorless and odorless, and you and I are breathing it in and out right now. But carbon dioxide is also a greenhouse gas. This means it retains heat. And if you get a lot of greenhouse gases, you're going to get something called the greenhouse effect. So let's learn a little bit about how the greenhouse effect works here on Earth. The sun shines light towards Earth, and when that light hits an object, it gets converted into heat. You've probably felt this before on a sunny day, even if it was cold outside. This heat then dissipates away from the object, and if we're talking about Earth, that heat is just going to get re-emitted back into space. But we have an atmosphere, and in that atmosphere are greenhouse gases like carbon dioxide that are going to work to bounce that heat back towards Earth. So now what's happening is the sun shines its light towards Earth, it hits an object, gets converted into heat, it goes to leave to go to space, but it hits a greenhouse gas, and that's going to bounce it back towards Earth's surface. And that heat might bounce a couple of times before finally going back into space. Now, the greenhouse effect is not bad. We need it. Without greenhouse gases, Earth would be way too cold for life to be sustained. But remember earlier when I said that humans are burning fossil fuels and we're releasing greenhouse gases like carbon dioxide? The amount of heat dissipating off of Earth is the same. That's not changing. But the amount of heat we're retaining has been increasing because of our increase in greenhouse gases. And so therefore, Earth is getting warmer. So now we know I turn on the light switch, it burns fossil fuels somewhere. Carbon dioxide gets released, and we know carbon dioxide is a greenhouse gas that's going to trap more heat. But how much of this heat is coming from humans versus just natural variation? So let's take a look at some data that is looking at carbon dioxide emissions from 800,000 years ago. Scientists have been able to measure carbon dioxide by literally sucking air out of air bubbles found in ice cores in Antarctica, which form layers just like rocks and soil. What they have found is that carbon dioxide has varied between 200 and 300 parts per million, or ppm. However, since the 1900s, that's increased a lot and fast. Present-day carbon dioxide concentrations are at 418 parts per million. This is so much higher than any time in recent history. So let's take a look at what humans have been doing that might help to answer this. countries around the world have been industrializing, increasing their reliance on carbon-based fossil fuels, therefore increasing our carbon dioxide emissions. Now, this all makes sense. What we're seeing is this increase due to the increase in fossil fuel emissions. Where the actual debate is how much higher is it going to get in the future? So thousands of scientists around the world are working together to answer this question. If we were to reduce our emissions, we can probably get to about 550 parts per million by the year 2100. But if we continue on, business as usual, we're looking as high as 900 parts per million. And while these are definitely going to make huge impacts on Earth, we're already seeing the impacts of climate change that we have to mitigate now. More greenhouse gases means more greenhouse effect, which means warmer temperatures. Since 1880, which is when we started reliably measuring global average temperature, the 10 hottest years on record have all been since 2010. The hottest year on record, 2016, was 1 degree Celsius hotter than the average over this time period. Now, I know what you're thinking. It's 1 degree. What's the big deal? Let's put that in perspective. The last ice age was only 6 degrees cooler than the current average temperature. So small changes in temperature are making a huge impact on our climate. Warmer weather means warmer oceans, which are going to fuel our hurricanes. In 2022, the hurricane season caused $56 billion in damages, and that was only the 6th costliest hurricane season. The most expensive in 2017 cost $294 billion in damages. And it's not just hurricanes. Warmer temperatures are affecting ice around the world. Glaciers that have been around for 10,000 years are rapidly melting, contributing to 8 inches in sea level rise. Antarctica has remained relatively stable, but the Arctic has decreased in size by about 50% in only 40 years. So why does this matter? Because you and I are making impacts every day with every decision we make, and it affects our carbon footprint. Now, I don't want to leave you all with doom and gloom, so let's talk about some things that you can do to help make an impact to your carbon emissions. First, you can vote for candidates who support green initiatives. We need laws from the top down to put regulations on our biggest polluters, industry. On a personal level, you can switch to a more plant-based diet because animal products produce and use a lot of our carbon resources. You can turn off those lights and other electronic devices to reduce the amount of electricity that you're using. And if you're going to use electricity, try to source it from renewable energy whenever possible. And finally, you can take Biology 105 here at Montgomery College. In this environmental biology class, you'll learn a lot more about climate change, what it is, how you can affect it, as well as other environmental issues. So unfortunately, yes, humans are the cause of climate change, but fortunately, that also means we can be the solution, and that is why it matters.